and page number? Students, can you tell me the chapter number and page number? Which chapter we were discussing? Which chapter was going on? Chapter number 7 is completed. Seven is completed. Okay, then which chapter was going on? I think एक chapter चलेगा. Okay, so let's start with chapter number. No students, but chapter number 8 will be there in science 2 section, right? Yes, chapter number 8 will be there in science 2 section. Chapter number 7 will also be there in the science 2 section. Yes. Then what about chapter number 3? What about chapter number 3? Lesson number 1 is completed. Yes, we were discussing this chapter, chapter number 3, current electricity. So what we have discussed in the last class is the conduction. Okay, free electrons and current flowing through a wire. So you are talking about free electrons. So free electrons helps to conduct the electricity from one end to another end. So any metal or any compound which is having free electrons are said to be good conductors of electricity. Okay, there are good conductors of electricity, there are bad conductors of electricity. So the substances through which electricity can flow are known as good conductors of electricity, and substances through which electricity cannot flow are known as bad conductor of electricity. So whichever substance which contains free electrons are said to be good conductor. So every atom of a metallic conductor, so conductors are usually made up of metals. Whatever conductors are, they're good conductors. They are usually made up of metals. And why they are made up of metals? So this thing we have discussed. Can anybody answer now? Can anybody answer now why metals are good conductors? See, metals have free electrons. Metals have free electrons, and from where these free electrons are coming? From where these free electrons are coming? If you consider the atom of metal, this is the nucleus. This is the atom of metal, okay? And outermost shell, this shell, this outermost shell is known as the valence shell. This outermost shell is known as valence shell. So the electrons which are present in the outermost shell of metals are very loosely attached. Electrons which are present in the outermost shell of metallic atoms are very loosely attached, and so since they are very loosely attached, they can be easily removed from the metal, and so if they are removed, it means we are getting free electrons. If they are removed, means we are getting free electrons, and whenever free electrons are present, the conduction of electricity is possible. So presence of free electrons is very much important for conduction of electricity. And since in metals electrons are loosely bounded, electrons are loosely attached, so they can be easily removed from the outermost shell. Okay, and the metals can act as a good conductor. Now this thing also we have completed current flowing through a wire, and what we have studied here is, suppose you have any metallic wire. Suppose you have any metallic wire and these contains electrons. So first case is the random motion of electrons in the wire, means when there is no electricity supplied. When there is no electricity supplied, so all the electrons which are present in the metallic wire are randomly arranged in any direction. Okay, no particular direction is there. But when the current is applied, if you see the when the current is applied, so what will happen? The electrons are arranged in a particular direction. Electrons are arranged in a particular direction, means all electrons are moving towards the positive side. So this is the positive side, this is the negative side. So when the electricity is applied, since electrons are negatively charged, so they will be attracted towards the positive end, and so they start moving in the direction. And next is the electric current. So last time we were on page number 37. Really? We were on page number 37. The next is system of resistors and effective resistance. Now we need to understand the resistors in series and resistors in parallel. So this is a circuit diagram which is shown here, resistor in series, study figure 3.8. You can see that the ends of the three resistors are connected. So this is the resistor, you can see R1, R2, R3. R1, R2, R3 are the three resistors. Okay, what do you understand by resistor? See here, the definition of resistor is also given. A resistor is a two-ended component. Two-ended component, it is having two ends on both the sides, having a given amount of resistance between its two ends. Okay, particular resistance is being put down in the resistor so that the excess current flowing in the circuit will be prevented. Okay, excess of current in the circuit can be prevented. So resistance is also important. In several electrical devices, a number of resistors are connected together. So if you see here, R1, R2, R3, three resistors are there. Okay, can you see three resistors are there? R1, R2, R3. Okay, so these are the three resistors. And what is the work of the resistors? What is the work of the resistor? Resistor develops resistance. Okay, resistor develops resistance. What is resistance now? Resistance is the ability to stop the electric current in the circuit. Okay, so that excess current cannot flow and the melting of wire does not take place. So in such an arrangement, the same current flows through each resistor. The value of current is I and the potential difference between C and D is V. Because all the resistors are connected one after the other, you can say after R1, R2 is connected, then after R2, R3 is connected, and all the resistors are connected in the same line, in the same position. So the current flowing through each resistor is the same. And such type of arrangement is known as resistors in series or series arrangement. So here if you want to know the potential difference, since they are connected directly one after the other, so if you want to know the potential difference between these resistors, we have to directly add, that is V is equals to V1 plus V2 plus V3. Okay, and here resistance in series, it is written as RS. RS is resistance in series, which is the effective resistance, and according to the Ohm's law. What is the Ohm's law say here? We have studied Ohm's law here. See, this is the Ohm's law. What is the Ohm's law? Tell me. V is equals to IR. V is equals to IR, right? V is equals to IR is the Ohm's law. So here V is the potential difference, I is the electric current, and R is the resistance. See, same thing is applied here. Same formula is applied. Ohm's law, V is equals to IR. But what type of R here we have? We have your resistance in series, right? We have resistance in series, so we are going to write RS. Yes, we are clearly defining that here the resistance which is there, which is in series. So it is RS. So we have three resistance, right? We have three resistance. So if we take individual, ठीक है, हर एक का अलग अलग, अगर हर एक पे अलग अलग ohms का apply करेंगे, so it is V1 is equals to IR1. If you want to take for R2, so it is V2 is equals to IR2. Formula is same, just 1, 2, 3 is changing, right? V is equals to IR. The formula is same, just numbering is changing 1, 2, 3, that is V1, V2, V3, R1, R2, R3, like that. Then again, since it is in series, just now we have said na V is equals to, wait, I will show you by writing. V is equals to V1 plus V2 plus V3. No, V is not velocity here. V what we are using here in this electric current, V is the potential difference. Okay, V is not velocity. This is the potential difference. For velocity, you use small v. Velocity के लिए जो v use करते हैं ना हम, that is a small v. And you can see here in the textbook, the v which is used here, that is a capital V. And capital V is used for potential difference. Okay. So understand the difference. Small v is for velocity and capital V is for potential difference. So we know that v क्या होता है? V is IR, right? V की value क्या है? See here, V is equals to IR, right? Yes. So here also for V I am writing IR. हर v के जगह पे IR लिखेंगे. IR, then here it is IR1, then here it will be V2 के लिए IR2, V3 के लिए IR, 3. Right. So here, since we are talking about series, so I am going to write here S. I'm going to write S. Then what we are going to do? We are going to take I. That what is I? Can you tell me what is I? V is potential difference. R is resistance. What is I? Current. Yes, Ariba. Very good. I is current. So see, now we are going to take I common. Yes, Hamza. Very good. Here we have I RS, and then from this side I am going to take I common, R1 plus R2 plus R3. Okay, then cancel out this I. Then what is left? See what is left? RS is equals to R1 plus R2 plus R3. R1 plus R2 plus R3. So this is the equation what we got. This is the equation what we got. Understood? Any doubt is there here in resistance in series? Okay, no doubt. Now proceeding next. Now next is resistors in parallel. Okay, so you have only two type of connection: resistors in series, and second is resistors in parallel. So resistors are said to be connected in parallel when the ends are connected at both sides as shown in the figure 3.9. You can see the figure 3.9. Again here you have three resistors R1, R2, R3. Okay, how you understand if R is not written but the symbol is like this? Okay, so you should understand that it is a resistors. Okay, resistor has a symbol like this type of symbol is there. So wherever this type of symbol is there, you should understand that it is a resistor. So what is the difference between series and parallel? Can you tell me regarding the connections? Can you tell me what is the difference here? Think about it. What is the difference between connections? Series वाले connections में और parallel वाले connection में क्या difference है? See students, what is the main difference here when we are talking about resistors in series? The end of one resistor is connected to the end of another resistor. Okay, yes, we know that के series में बाजू बाजू में लगा हुआ था, parallel में सामने सामने, but such type of thing we cannot write in the paper, right? ऐसे हम नहीं लिख सकते ना series में, this is one after the other. So you need to explain in a very precise manner regarding the connections. So talking about the connections, how you can say is that in series, this is one resistor, this is another resistor, and this is another resistor. Okay, so end of one resistor is connected to the end of another resistor, right? End of वन रेजिस्टर, एक रेजिस्टर का एंड दूसरे रेजिस्टर के एंड से कनेक्टेड है डायरेक्टली, राइट? Yes. Now, what in case of resistance in parallel? In resistors in parallel, if you see, this is one resistor, another resistor, and this is another resistor. Okay. So ये तीनों के तीनों आके एक ही जगह पे combine हो गए. All the three resistors are combining. All the three resistors are combining at one position. All three resistors are getting combined at one position. Okay. So this is the difference between resistors in series and resistors in parallel. So in series, every resistor is connected to another resistor directly. Okay, one after the other. The connections are direct. And here in case of the resistors in parallel, all the resistors meet at a particular point. Then again, if you want to know the total current flowing through the circuit, because why we are joining the circuit? Because we want the current, right? We want the current to flow through the circuit. That's why we are making the circuit. So how we are going to find out the current? Again from the Ohm's law. Okay, again we are going to use the Ohm's law. So this Ohm's law is very important in case of electric current. So you should remember what is the Ohm's law. Ohm's law is V is equals to IR. This is the Ohm's law. V is equals to IR. So if you want to know the current, what you will do, you will put I on this side only, and then V upon R, right? Understood? So in this way, you are going to get the current flowing through the circuit. Now, because we have resistance in parallel, so you are going to write RP like this. Okay, because we have resistance in parallel, so you are going to get RP. Yes, P for parallel. Then again, see, we are going to apply this formula and derive one short derivation. Yes, now total current which is flowing in the circuit, total current which is flowing in the circuit, it will be equal to I1 plus I2 plus I3. ओके, पूरे सर्किट के अंदर जो भी करंट फ्लो होगा वो डिपेंड होगा कि I1 R1 रेजिस्टर्स की तरफ से, R2 रेजिस्टर्स की तरफ से और R3 रेजिस्टर्स की तरफ से कितना करंट फ्लो हुआ है. सो I1 I2 I3 is important. Okay, so directly how we can write, just now we have seen that I is equals to what? V upon R. I is equals to V upon R. So in case of this formula, again we can write I is equals to V upon R. मतलब जहाँ जहाँ पे I है वो सारे जगहों पे हम लिखेंगे V upon R. Right? We are going to write V upon R on every side. So here also V upon R, V upon R, V upon R, V upon R. But we have R1, we have R2, we have R3, and again we have resistance in parallel. So we have RP, R1, R2, R3, and RP. Now again, what you can do? Tell me the next step. What is the next step here? What will be the next step? In last equation, what we have done? V की जगह 1 आएगा। कैसे आएगा V की जगह 1? कैसे आएगा बताओ? फिर स्टूडेंट्स इन द लास्ट टाइम वी हैव टेकन कॉमन, है ना, हमने कॉमन लिए थे। अगेन हियर आल्सो वी आर गोइंग टू टेक कॉमन। So here you have V upon RP, okay, and here also I have V। तो मैं V कॉमन ले लूंगी बाहर, तो अंदर क्या बचा 1/R1। सेकेंड वाले का भी V बाहर आ गया, so again 1/R2 is left, and in third case also V is taken outside, so it is 1/R3, right? And then this V and this V is going to get cancelled. This V and this V is going to get cancelled. So what is left is only 1/RP. ऊपर वाला V cancel हो गया, means nothing is there. Nothing is there, so you cannot write 0 according to the rule of mathematical calculation. You have to write 1, right? So it is 1/RP. 1/RP is equals to 1/R1 plus 1/R2 plus 1/R3. In this way, you are going to get this formula. Okay, any doubt is there here? Anybody wants to ask anything related to this topic? Resistance in parallel? No. Okay. So here it is formula we have got. Now students, do you remember what are these components? What is A, what is K, what is E, which is given in the circuit? What is V? Can you tell me? ये सब क्या है? What is K, A, V, E? Can anybody tell me what is K? No, not full form. I'm not asking about full form. I'm asking K का मतलब क्या होता है? यहाँ पे जो circuit में K लिखा हुआ है, what do you understand? Yes, you can also say it as a full form. What is this K? What is this K? No, constant proportion नहीं. Potassium, अरे, how potassium? We are talking about electrical circuit, students. We are talking about electrical circuit. Circuit में potassium वगैरह नहीं add करोगे. Not a constant proportion. That proportion and all the things we write in the equations. This is not the equation. This is your circuit. Try to remember. I've explained you. I've explained you what is this. All these components. What is A? Tell me what is A, which is shown here. This is A. See, this is A. Tell me what is this A, and what is this V, which is shown here. V, and this K. So students, here A is the ammeter. A is the ammeter. Actually, I have explained you this thing, but I think you forgot. A is the ammeter. What is V? V is the voltmeter. Okay. What is the use of ammeter? What is the use of voltmeter? Now tell me. Here A means ammeter and B means voltmeter. Voltmeter helps to measure the potential difference. Okay, voltmeter helps to measure the potential difference. And what about A ammeter? Ammeter helps to measure the electric current. Ammeter helps to measure the electric current. What about K? What is this K? K is the plug key. K is the नहीं केल्विन नहीं K यहाँ पे plug key सर्किट के अंदर जो K होता है that is the plug key. What is the role of the plug key? What is the role of the plug key? Plug key is very important in the electrical circuit. What is the work of this plug key? Forgot everything. Suppose this is the wire and this is again the second end of the wire, okay? And this is the plug key. ये क्या है? ये plug key है, okay? So now if you see, the plug key is open. Here the plug key is open. देखो यहाँ पे connections जो है वो joined नहीं है तो इसका मतलब है plug key कैसी है? Open है. The plug key is open. If the plug key is open, the current will not going to flow. The current is not going to flow. ना current जो है, whatever current is there, that current will come and stop here. यहाँ नहीं जा पाएगा. Current is not going to flow there, right? So current is stopping at this position. So if you want the current to flow through the circuit, what you will do? You need to close this plug key. You need to close this plug key. तो जैसे plug key जो है वो close हो जाएगा, then current will flow from the circuit. So plug key helps to regulate the flow of current. If you want to stop the flow of current, you have to open the plug key, and if you want the current to flow through the circuit, you have to close the plug key. Okay, so this is a very important role of plug key. So you just go through this, all this thing, extra information which is given to you, just go through that. And then the formula we have discussed, right? This formula we have discussed, so I hope you will be able to do it, right? You have to just put the resistance values. सिर्फ put करना है, R1 कितना है, R2 कितना है, R3 कितना है, just you have to put out the values and then you are going to get the answer. The resistors having resistance of 15 ohm, 20 ohm and 10 ohm are connected in parallel. What is the effective resistance? So the formula is given here. This is the formula. Okay. This is the formula for effective resistance. So what we have to do is we have to just put the values of R1, R2 and R3. Put the values of R1, R2 and R3. And then carry out the simple calculations. Any doubt is there here? Okay, so we have completed with this chapter. And if you don't have any doubt, so we can end the lecture. Anybody wants to ask anything? Okay.